Good morning, good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our webinar, AI Factories at Scale, Unlocking Innovation with NVIDIA and HPE, brought to you by our friends at Hewlett Packard Enterprise and NVIDIA. I'm Brian Mink, co-founder and president of Data Science Connect, the world's largest data and AI community. Today, we're excited to welcome hundreds of attendees from all over the world to discuss the infrastructure backbone powering AI innovation at scale. As AI initiatives grow more complex, enterprises face mounting pressure to support high-performance model training, inference, and data movement without compromising efficiency. This is where scalable end-to-end infrastructure becomes mission critical. That's the promise of the AI Factory. Today, we'll explore how NVIDIA's accelerated computing and HPE's enterprise-grade platforms work together to deliver integrated AI infrastructure that scales with demand. From streamlining workflows to enabling real-time performance across sectors, you'll walk away with a clear picture of what it takes to operationalize AI at scale, today and in the future. Before we begin, a few housekeeping items. To make this feel a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and any other information you want your fellow attendees to see. Also, please take advantage of the Q&A and chat features in the right sidebar. We'll be addressing your questions at the end of the webinar, so be sure to upvote the ones you want the panel to address. Now I'd like to introduce our distinguished panel of experts. We have Kaushik Shirhati, VP of Global AI Networking at NVIDIA, Bhuvana Gudad, Chief Technologist, Worldwide ANPS AI Services at HPE, and Steve Highbine, Federal AI Chief Technologist at HPE. Now, before we kick things off with our panel, we'll do a quick intro video from our friends at HPE and NVIDIA.
Unlock AI. Unlock the potential to do more, solve more, discover more. Hewlett Packard Enterprise and NVIDIA unlock the power of generative AI, combining HPE's enterprise-grade mastery with NVIDIA's revolutionary AI breakthroughs. We're co-developing and co-innovating to simplify the complexities of AI, making it easier and faster to deploy. Not only are we building and creating together, our combined solutions empower teams to do the same, scaling AI from individual data scientists to an enterprise-wide platform for innovation. With all these things coming together as one, organizations can deliver on AI-driven business outcomes faster, seeing results in weeks instead of years. Welcome to the new world of NVIDIA AI computing by HPE. It's time to unlock AI.
All right, and with that, I'm going to turn things over to Kaushik. Welcome, Kaushik.
Thank you, Brian.
Thank you, and you have the stage.
Good morning, good afternoon, good evening to everybody joining from all over the world. We're super excited to talk about NVIDIA and HPE's AI factories. Easy is hard. Making something look easy, seamless, effortless is extremely hard. At HPE and NVIDIA, every single thing we do is in the service of AI. We make it extremely hard on ourselves to make it easy, seamless, effortless for our customer. But the first question here is, who's our customer? It's not the large cloud providers. It's not the AWS and the GCPs of the world. It's not all the partners in the ecosystem. It's not enterprises like Bank of America, 7-Eleven, Charles Schwab, Kaiser Permanente. We are all partners here. Our real customers are the end users and the machines who are harnessing the power of AI to make lives better. It's the clinician who's working at Kaiser Permanente who can go home at 5 p.m. because she is using a bridge which is using our factories so that she doesn't have to do all the manual work. If the father who's using Grok from XAI to write a beautiful, sweet letter from the tooth fairy for his 7-year-old daughter, and the smile that you see in the morning, that's priceless. That father was me a couple of months ago, and I did not use the unhinged mode of Grok. And so at HPE and NVIDIA, every single thing we do is in the service of AI. And our strategy is fairly straightforward. We collaborate with our partners, which is you, to help your organizations help realize the AI goals. And so to do that, we are deciding to build AI factories so we can manufacture intelligence at scale. Our strategy here between HP and NVIDIA is not to come to you and force everybody to buy everything we have, but we want to fling open our arms and we want to welcome you and show you the innovation, the expertise, and the effort that we've put together in building these AI factories. And our strategy is to continuously learn from each other, from you, what's working, what's not working. One of the things that my colleague Steve here is going to show you is our effort in the private cloud AI. And that's a great example of innovation. When we started going to different enterprises, what we realized is that we have an amazing software with NVIDIA AI enterprises, but we quickly realized that what we wanted to give the enterprises and what the enterprise was asking for us for were the blueprints. And so we quickly were able to bring out the NIMS blueprint. And in collaboration with HPE, we're able to launch private cloud AI where a user can actually go in and quickly access these blueprints. And so NVIDIA bet on AI way before anybody else did, and so did HPE. We've gone through a journey of 10 years, and in the last 10 years, we've learned a lot. We've made mistakes, we have innovated, and after 10 years, when we look back and look at the AI journey when an organization takes, we are able to distill the journey in three distinct phases. And I'm sure all of you guys have experienced these phases or are experiencing these phases. The first phase is when an enterprise and an organization embarks on an AI journey, we're able to, the first challenge that you face is prioritization. There are lots of ideas across the organizations from all different places. And the challenge is to go figure out, well, which idea is real, which idea is going to bring the most value, which idea is going to be sustainable. And so that itself, the prioritization is a big challenge. Once you prioritize it to your top 5 or top 3 or top 10, then the question becomes of data, right? Is my data clean? What are the sources of the data? How do I think about pipeline? How do I think about automation? How do I think about, augmenting that database with a RAG database or a vector database? And so once you've gone through all of that, that's when you start thinking about the infrastructure. And so essentially today, an enterprise, when you start thinking about the infrastructure, you have three choices. One is you can go to a large cloud provider and you can start renting an AI factory there and you start your AI projects. Or you can go to specialized cloud providers today around the world that are building AI factories for you to rent, or you can start building it by yourself. And if you're building it by yourself, then you have to start thinking about power and cooling and the data center choices. You want to start thinking about what GPU to use, what your workload looks like. Is it training? Is it inference? What networking to use? What system providers, certified vendors that you're going to use. So once you've gone through all of that, then you really start thinking about the deployment and you start thinking about the cost. You think about security, you have to think about customization. And both of these phases are extremely important and they matter, but they also don't matter. For the dad who's using XAI, It doesn't matter whether it took hundreds of engineers to go stand up a cluster of 100,000 GPUs. What really matters is the third phase. And the third phase is the time to first token. It's the time to first inference. It's the time to train. And ultimately, it's about time to wow and time to value. And so this is what an NVIDIA HPE AI factory blueprint looks like. So what is an AI factory? At a very simple concept, this is the factory of the intelligence age, where you are putting in electricity, you're giving the data to the factory, and magic happens, and out comes the tokens, out comes the business outcomes, out comes the intelligence. And so the easiest way to think about this factory is think about a 4x100 relay race. When you want to go build an Olympic winning 4x100 relay race, what's going to happen is you want four amazing sprinters. But having four amazing sprinters like Shakira Richardson or Usain Bolt is not enough. What you need is the practice. The only way teams win is when the handoff is perfect. And so we are extremely blessed here between HP and NVIDIA that we have four amazing sprinters. We have the compute, which is the heart of the factory. Our Blackwell and Hopper, in combination with HP certified system, whether it's a Cray system or ProLine system, they turbocharge the factories. The second sprinter is the networking. The network is the backbone of the factory. The InfiniBand and Spectrum X platforms, they optimize all the communication of the factory. The third sprinter is our software. The software is the operating system of the factory. The software is essentially brings out all the goodness of the factory. The software, whether it is NVAI, whether it is GreenLake, whether it's private cloud AI, that is the place where the intelligence is generated. And then we have all the software that optimizes the infrastructure of of the factory. And then the last but not the least, our sprinter is our ecosystem, which is all of our partners in the ecosystem, our developer communities, is the Accenture and the Deloittes of the world. And it is all of you guys. You guys are our partners. We are working together to ultimately make it easy for the end users. And so when we look at the factory, as I said, having four sprinters is great, but that's not enough. The real value is in the handoff, and that's guided by our reference architecture. That's the blueprint for the factory. And so the handoff is the practice when nobody is awake, when nobody sees that practice, which is all the optimizations that we do, all the simulations that we do, all the when we start from a workload of a particular industry, from the software down to the hardware, how, for example, how nickel works, right? How they talk to our NICs, how it goes to the network. And so all of that is optimized in that handoff through our reference architecture. And so ultimately, it's not about how fast is the GPU, how fast is the network, or how optimized is the software. We can spend hours talking about the performance of each of these printers, but the real magic happens when it compounds together, when it all comes together to deliver the time to value, the time to wow. And that is why HP and NVIDIA builds our AI factories. And so, this is where I'm going to hand it over to Steve, and we're going to talk about the HP and NVIDIA AI factories and how they are manifesting and how they are solving enterprise problems. So with that, Steve, over to you.
Great. Kaushik, thank you very much for that introduction. And I should have my slides in a second. There we go. Well, one thing that we've been doing is you can hear from what Kaushik was saying, how NVIDIA, AI, and HPE are getting together in a way that what we can do is present, take the best of what we learned through the people, the technology, and to provide great economics for a variety of different things. Whether I talk about the turnkey private cloud, which I'll be mentioning in a little bit, our AI services, which Bhavana is going to be talking about, optimized systems, which again is just a thread that runs through all this, and all the enterprise grade support and control that you need to deliver the types of things you see on the right-hand side of the screen. That inference, training, virtual assistants, process automation, etc. So what we want to do is we want to be able to simplify this. Kaushik talked about how the difficulties that are presented. Well, what we want to do is say, well, how can we simplify that? How can we make this journey simpler and successful? And so what we've been looking at is ways that we can, together build out, whether it's a DIY AI factory, a private cloud where we bring this from out in the public cloud to on-prem, where you have sovereignty with the data and the intellectual property that you have there, or whether you're talking about something that's an AI factory at scale, very large scale factory. Now, we look at it like there's three different ways to AI productivity. And when you think the simplest way is there's an AI application, some packaged AI, maybe it's something like surveillance. You want to use that image analytics. What I might be doing is fraud detection, or something for shopping recommendation. Those are things almost like right out of the box. You can put these together, but these are packaged AI applications. There's really no code development that goes on with that. It's really configure, go, and it'd be a case where, say, I need this many cameras to cover this high school or whatever it might be. I would pick the software I need and the features I need from that software, and it would actually dictate how many servers, how many GPUs, what type. So very simple, single purpose, right? Next thing I want to talk about then is I'm going to go into the turnkey AI factory. This is where it's all in one. It's everything is there in that platform. What we've done is we've created although it sounds funny, an opinionated software stack. It's basically what we have learned through HPE and NVIDIA, that these are the items that you want in the software stack. And then we do this in t-shirt sizes because not everything fits everyone. So what we want to do is say whether I need small, medium, or large, or even need even long t-shirts to give you that kind of flexibility. So this way it's sort of pre-sized that you can sort of go through and what is my workload to fit on there. But what these are be built out to be able to create or deploy AI applications. And then the third one is where it's a custom AI factory. When you're really talking about somebody wants to do a specific thing, they're building out certain types of products, they're using it possibly for training new models, but also deploying models. It could be even all inference, but those are custom solutions. But what we do is we build them on a proven architecture. So these aren't things that, although each one's custom, it's not a case where we haven't done this before. What we do is use proven architecture, a blueprint for being able to create reproducible success. Now, let me break that down a little bit. Like I said, I mentioned the DII, the single purpose. It's really, we have, working with NVIDIA, they have a catalog of over 1,500 different AI applications that are there. And I'm sure these are just a list of a few of them that you'll see the logos on the right-hand side. But whether it's data analytics, surveillance, medical imagery, chatbots, etc., there's applications on there. These are the simple ones where we say, okay, this application to run this many users, you need this size. Now, here's where you start getting into where it's interesting. What we've done together is to build what we call HPE Private Cloud AI. This is a co-developed solution with NVIDIA. And so what we've done is we give you that cloud experience on-prem. And so what now you're dealing with is you have that same type of experience, but at a fraction of the cloud costs. As many of you maybe have found out when you're working in the cloud doing AI, those cloud costs can get out of control. Well, this way it gives you a way to control those costs, reduce those costs, and actually have the capabilities that you need to try out things. But these are built for deploying and developing and deploying like Gen AI, machine learning, deep learning type of applications. What's interesting is what we built with private cloud AI. It's actually one-day installation. It comes, the rack is totally rack, stack, cabled, and in there you have everything you need. There's a robust software stack, there's high-performance hardware, there's networking, there's all cabled up storage, etc. And then what we do is even build in some quick start solution accelerators, and we use the NVIDIA, and we also use the NVIDIA blueprints, software blueprints, so that you can bring up applications relatively quickly in a development cycle. One of the things we include in there is what we call a no-code, low-code RAG. And for those who aren't familiar with the term RAG, it's retrieval augmented generation. And think of it this way: when I'm doing a chatbot or generative AI, what I can do is say, well, normally it gives you answers that are generic to whatever it was trained on. Well, what if it could be trained on your content? And that's what RAG does. It retrieves your content, it augments that large language model, and then it generates answers using your content. So it's very personal on what it is in your either your vertical, your science, your company's assets. So to build this up, you saw Kaushik showed that stack, right? These 4x100. Well, what we've done is this sort of laid out a little bit differently, but it still includes all those components. And you'll see at the top in the NVIDIA green, talking about the community, the partners, and different custom software you might do in there. Also, their NVIDIA NIM. It's their NVIDIA Inference microservices. Think of it as a way to capture a lot of this capability into a container. And so in that container, that was the thing that gave you all that performance increase that Kaushik showed earlier in about his last slide there. And so because they're so highly optimized, you get extra performance. And then, of course, there's the NVIDIA AI Enterprise software. That enterprise software, as he mentioned, and actually Jensen Huang says it's the operating system of AI. Well, what we do is we put HPE AI Essentials on there as sort of the user interface. Think of that as the GUI, as the user face that sits on top of that OS to give you the look and feel, to make it very simple to be able to pick tiles to actually run different applications and things on top of that. As you see, there's the NVIDIA GPUs and networking. And what we do is we put those inside of our HPE AI servers and use our HPE file servers and storage to go along with this. And of course, there's AI services by both us, NVIDIA, and other parties that are available. In the case of HPE Private Cloud AI, what we do is we actually bundle in quite a few services to make sure this is a turnkey solution, white glove delivered. From the moment this moves from your loading dock onto your data center floor, it's usually within 24 hours, we have that up, operating, and we actually show you how you can use that, like I said, that no-code, low-code RAG to be able to take some of your content and incorporate it into a chatbot or different tool like that. So what's interesting is on the right-hand side, those are things that we've done that taking advantage of HPE's GreenLake. We call it the cloud that comes to you, but what it is it gives you a cloud experience on-prem. And so because of it, all these things that you need that aren't AI related, but actually to run this in a data center, run this in an environment where you have to do the setup, inventory, IT and asset management, lifecycle management that goes along this, workload provisioning, be able to launch your applications, doing orchestration, management. And then you got whether it's VMs or Kubernetes. And then also these are built as multiple servers. So there's cluster management involved. And then, of course, there's observability. You want to be able to monitor what's going on, observe it and such, and be able to show back or pay back or show back how much utilization that you have in there. You can see on the purple layer, it says, all the different, small, medium, large, extra large. And there's also a developer system I'll mention in another slide. So here you can see some of them. And let's focus on the right-hand 4. If you think about it with the small, medium, large, it gives you the opportunity of how many GPUs you need, whether it's 4 or 8. And it is like I've got a small shirt, but I can have it small, regular, or small, long. Okay, that's the best way to look at it. So what you've got is there 8 different size systems to build from the small, medium, large, extra large. The Blackwell one, I'll talk about that in a second, but you notice what they include is the GPUs, storage, networking, and it's all built in a rack. And with that rack, what we do is we have redundancy built in there. So we have 3 servers. If you look sort of towards the top, you'll have networking. Then here you have your 3 servers, which are control servers to be able to say, I can run Kubernetes off of that, cluster management off of that, login nodes. So you have redundancy as you're going in there. And then what you'll do is you'll have in your compute servers with your GPUs, and then moving down farther on this stack, that's actually, you'll be your storage servers to go with it. So whether it's small, medium, large, extra large, as they get larger, obviously it's up to a 2-rack configuration. But what's also interesting is for some people say, right now, I want to use that same software stack you've been talking about, but I want to use it in a development system because I don't know yet, is my problem going to fit in, which t-shirt, right? And so what we have is we have a developer system, which in this case gets mounted in your own rack, and it does include some storage and all the server capabilities, but can run all that same software. You don't have the redundancy that you have in the other systems. And this is really set up for development, not necessarily production environment. It wouldn't fit in that sense. But what it does, it gives you that way to start fast. Or, if you want to scale fast, what we're doing is we're going to have a Blackwell system coming out. That'll be in the second half of this year. I would likely suggest that we'll probably actually mention it at Discover coming up in June. Now, then there's a custom AI factory, right? That was a turnkey one. Everything is, like we've already thought this out, what that whole stack is. But when you come to a custom AI factory, that's a case where we're going to take advantage of that stack that you saw, that Kaushik showed, a variation of what I just showed. And what we're able to do is build this in a way for your needs. It'll include still the high performance accelerators, network storage that you expect, and it'll be customer-driven software stack. So if you've already been developing and you're in a situation where I've already been doing HPC or AI, what we'll do is that we call that a brownfield, right? You've already got something that you like to use, and what we'll do is we can adopt the hardware architecture, the network architecture, the cluster architecture to fit in with that software stack. But many people say, okay, I'm new to this. This will be my first one. And so what we can do is we can, again, provide this software stack from top to bottom, everything you need to include in there. And so that'll be, and many of these systems, they're going to be air-cooled or liquid-cooled. As you get to more and more performant GPUs, they require more and more power. And with power, there also requires cooling because all of that power goes into heat. We're finding that these things, we can work an on-prem, a colo, we can build that out as a service. There's a variety of different ways we've been building these out for our customers. So, and then when you look at the components that are in there, we'll work with NVIDIA with their CPUs, like their ARM chip that they use, the Grace ARM chip. And then also NVIDIA GPUs, whether they're Hoppers or whether they're Blackwells or where, so a variety there, the networking, interconnect, and then storage, development, management, et cetera, things that we've been doing for decades. Now, some of the components that we'll build up from, whether it's the NVL72, which think of that as a cluster that's built so that it's not, although it's rack scale, it's really a case where this is where you're going to be doing 8 of these racks or more, and you build them in building blocks like that. We also have the XD, which if you're familiar with the NVIDIA DGX reference architecture, what we've done is the DGX reference architecture, what we're able to do with that is build that out. But then what we can do is we can be twice as much memory or half as much memory with disks, without disks. So what we have is a variety of other servers along the line that can sort of satisfy every size and scale. And we can build these into clusters to whatever's required for your needs. So, but other things that we believe that are really strong is in an AI factory, you want to make sure it has multi-tenancy capability, because when you've invested a large amount of money, a large amount of energy, what you want to do is you want to make sure that you can take you can support as many tenants within your corporation, within your organization, within your agency. Dynamically provide GPUs as a service. Extensive automation, self-service, so it's self-provisioning. So as they come on, you don't have a big work effort involved with that. Also automated resource monitoring, billing. So bill back, show back, pay back, as they say, for those things. Central control and observability. And then finally, you want to provide other value-added services that might make sense. Similar to those blueprints we talked about earlier, those reference projects, et cetera, to make that, build that out. Here's an example of 3 different situations, factories that we built out for different organizations. And you'll see whether it's Los Alamos National Lab in Switzerland and over in Britain. These were all ones that are very powerful. And you sometimes wonder, wow, 10 exaflops, 20 exaflops, 21 exaflops. Why do I need this type of performance? Well, when we're starting to develop and you're seeing pharmaceuticals trying to develop new drugs, or you're seeing research organizations are trying to find ways to be able to solve other grand challenges like global warming or such, or whether you're an organization that says, I've got a product that I want to optimize, or I'm trying to build out and I want to be able to make sure that my chatbot can support thousands or tens of thousands of people and queries per day. But with all that power, I mentioned earlier, comes heat. And so you'll find that GPU power is going up, CPU power is going up, but then this thing called silicon temperature, the T-case, the actual temperature that it needs to be on the top of that silicon to keep it cool and running at optimum thing, is coming down. And the reason that's coming down is because these chips are now becoming, not just 1 layer, 2 layers, 3 layers, up to 4 layers thick. And so because of that, you've got to do a great job of cooling the top of that. So this way, all the way through that silicon can be cooled down. And so that's requiring, there's a point at which there's no longer, you can air cool it. If you ever think about, if you ever seen, even in a PC, they have the fins that come on top of the CPU. Well, what happens is the coolest part of the fins are up here. The warmest is right here by the chip. And so what you want to do is you want to, if you do direct liquid cooling, we're actually taking and cooling with the fluid right on the top of the chip to make it run in an optimal situation. We're also finding that sometimes customers say, well, my data center, I don't have liquid cooling. How do I can handle this? What we've done is we've been, over decades now, we've been doing modular performance optimized data centers. And now with AI requiring even more, we've made it so that these can be air cooled or liquid cooled that we can bring on site, and actually show you an example here of one of the ones that we did in Britain. And, Isambard, which is using the Grace Hopper chips from NVIDIA and the HPE server architecture in our HPE modular performance optimized data center. I want to pass this on now to Bhavana.
It was well articulated by Kaushik on why AI factory, what are the different challenges, and what all are the building blocks or the different components which would make the AI factory as a whole, right? It is not a single system, it is integrated with a lot of systems together, right? And then Steve walked us through on all the HP offerings along with NVIDIA and different customer with whom we work together to build the AI factory for them. And then not just that, the how do we handle the sustainability aspects from the HP perspective or the customer to help on the sustainability journey as well, right? So with that, the last leg would be on the services side, right? So we have products, we have everything. The last part is services, right? That's where the whole integration and plug and play would work, right? Once we talk about the product, how this product would get integrated within my data center, or how this would help me to build the applications, which I might have few applications which already exist in my environment and maybe building the new applications. But when I build a new application, at the end of the day, I cannot let go of the legacy things which I have already built for a couple of years, right? So that's where the services play becomes viable or becomes the more prominent for the customers, right? And with that, is it easy? Like, for the customers today, we see a lot of enterprise challenges when, especially when they are trying to implement these kind of solutions, especially which are surrounded with AI and Gen AI, right? And the first and the foremost challenge would be on the strategy and the readiness, right? Why this is utmost important. I'm just coming out of one of the AI workshop today with a customer where they have lot many GPUs within their data center. They have all the system ready, but they don't know what use cases they want to really build on top of that GPUs, utilizing those GPUs or utilizing that hardware, right? So having a right strategy along with a roadmap and having the right outcome assigned to those strategies, right? So when a business runs without the outcomes, I don't know where we are going to land, right? And this is the primary challenge where we have seen customers struggling, like, well, the technology is changing so fast, but how do I adapt to that technology and how do I build my strategies, right? Which would be really implementable, which are really robust and which are really scalable in nature, which would address across multiple views within my organization. Because if I create something siloed, then it would remain siloed as well, right? And I will not be able to scale. I will not be able to reuse any of the components which are built around it, right? So that's where having the strategy across or the broader strategy and then having an outcome attached to each of the business units makes a lot of difference. And one of the other challenge which I generally get to hear from the customer is on expertise or the skills today, right? Because technology is changing so fast that how do we adopt to it, right? So having the in-house expertise with all the skill set required for your generative AI, ML ops, AI, AI ops, all the ecosystem components, it's very difficult, right? So that is another challenge. Then it goes on to the scalable AI platform, right? So garbage in is garbage out. That's where the data comes into the play, right? So having the right data, which is processed, which is fine-tuned, which has a governance model attached to it, which is ready for me to consume for my any of applications. It could be AI applications or it could be a business applications, right? So having all these aspects of data is very much essential. And then tool chain, right? So many frameworks, so many tools are out in the market today. I think every day we are seeing a tool coming out of from the market, right? But then which tool is right for my use case, which tool is right for building or using my data, building the use case, and then how do I integrate with rest of the ecosystem components which already exist or I may require to integrate. Because if you think of complex solutions like MLOps, right? MLOps is not just one tool. There are multiple tools which get integrated to build that whole pipeline. And then how do you ensure that these tools are meeting all the needs? And how do you ensure that all the software recipes, because the versions keeps changing, right? How do you ensure that this version integrate with the another version of the same tool, right? So these are the complexities behind. So having this scalability at the application layer, not just at the hardware layer, is also essential. Then comes your operationalization and optimization aspect, right? So this is utmost, because when you bought a system, if it is not performant enough, then I think I'm not doing a justice to what I have bought for, right? So I have seen customers who say today, right, hey, I'm spending a lot of money on my inference, because that's where most of the vendors are charging the customers today, right? If you go back and understand or see, when the chat gpt was available, or OpenAI released the chat gpt, the inference cost was very high, right? But later on, the inference cost started dropping down. It's because the demand started increasing and there are a lot of vendors available, right? So always it's like, how do I optimize and have a right performance with the right cost is something which is really important for many of the customers, and they struggle here today, right? Not just that, and the another aspect to it is the governance aspect to it, right? So having the right compliance, because there are a lot of the compliance aspects which are coming out of the geos, right? uh, every geography is building their own compliance aspect. So how do you ensure that all the compliance aspects are met to ensure that whatever the model we are building or whatever the applications we are building is making real sense to the end user and at the right accuracy with the right data set and with the right the components which are used, and not having the data leaks and not making the different accuracies which is not really expected, right? So these all are the aspects which has to come together, but these are becoming the challenges for most of the customer today, right? That's where the services play a vital role, right? So if you see from the services aspect from those challenges, and if we tie those challenges back to the services, how do we see this whole portfolio, right? So we have different services which are available from day -1 to day 2, right? So when I think of day -1 to day 2, don't take it literally as the days. These are characterized from day -1 to day 2. For example, when the services engagement start, the first challenge which was around strategy, it's all around having the advisory and consultancy services which will help customer to define the use cases, the right ROIs, building the roadmap, the short term, long term outcomes, how is it, what is it, and what it requires, what data sources are required, right? Defining all of those aspects with a right stakeholders from different representatives or different representatives from the different BOs, right? Because the decision for the organization cannot be made by one segment, because if I make that, then again I'm creating a silo there, right? So that's where having the advisory and consultancy services for the day -1 is essential to build the right strategy. Well, some customers might say that, hey, I already have a right strategy, I have a roadmap, then what next, right? So that's where the design and planning would come into the play, where we define the high level architecture, right, with the right software stack, right hardware stack, and how the data sources would integrate, where it would fit, what it would fit, how many GPUs are required for what kind of model. So all these aspects gets into the design and planning mode, right? And also it defines the project planning, where it defines like the whole project end to end, be it a POC, POV, or a full grade production ready application, right? So you need to define different work packages, how the timeline is associated with those, and all those details. Once you have everything, boom, everything is ready. Now I'm ready to implement and integrate. That's where you kind of take in that and start implementing it on the real hardware. We have different implementation services, and then also integrate, right? Because when I think of any solution, I have to integrate somewhere. For example, the basic of the basic would be I would have to go and integrate it with that. That's where your authentication and authorization happens. So all those aspects has to be followed. It is not an independent solution or independent thing which I'm building. Somewhere it has to integrate, right? So that's where the implementation and integration services comes into the play from the day one perspective. Then it goes on to the day two. Actually, you have a system ready now, right? It's all about run and optimize. For example, you have built a application which could be a the ML model, right, with for predictive maintenance, right? Now how do I continuously or constantly keep updated with the components or the tools which are available within that stack? Not just that, the data set changes, the feature set changes. How do we keep up with all those things is where run and optimize comes into the play, where MLOps kind of services start playing uh, uh, the vital role there with a continuous integration and continuous delivery aspects, right? So it goes back to the day one and start trying to understand how do we optimize this whole stack, and how do we integrate, and how do we keep up with all the changes which are happening across, right? So all this is fine. Then would be the next question would be having the right skills, right? If you see that on the left side, you have AI skills, which is another important aspects, because sometimes I have seen the organization where uh, you know, we don't have a data science team within our organization who would build this application for us, right? So we have worked with customers where we have built the application and then hand it over to them for to maintain, right? And there are customers who don't even want to maintain it; they want to have something offered from the HPE, right? So that offering is also available, where you can have an application built and support and services available from the HPE side to the customer, right? So there are multiple ways where the services can spread across from day -1 to day 2, right? With that, what are the different services available across the ecosystem, right? So you can see it just doesn't talk about the AI all alone, because AI is not an independent technology which exists. AI needs a right data if it has to be successful. It needs security if it has to be successful, again, because I don't think so any customer would agree to buy something which is not security ready, right? So the services also cut across the similar way, where we have data and security services defined for day -1 and day 02, right? Where data, if customer says that we don't have a data platform strategy, where we help customer to build the right data platform strategy with identifying the right data pipelines, the governance aspects to it, everything, right? And along with that, the cybersecurity aspects to it in terms of the risk assessment, the model assessment, right? So even now the prompt injection, guardrails, right? So all these aspect has to be covered from security angle as well, right? So this is the whole spectrum of services which spread across from data, AI, and security. With that, I will hand it back to, okay, sorry, last slide. So this slide, the essence is to show the close integration or the close knit between HPE leaders and the NVIDIA leaders, where we are co-working together to deliver the right enterprise grade solution, which are secured, which are scalable, flexible enough for customer to deploy their use cases and achieve their ROIs or the outcomes which are really required for them. With that, let me hand it over to Brent. Thank you.
Thanks, Bhavana, and excellent presentation. And we're going to bring Steve and Kaushik back to the stage as well. We have time for just a few questions. So I want to kick things off with you guys by just asking, first off, as kind of a high-level recap in one phrase or a sentence, what is your top insight for enterprises aiming to unlock innovation with AI at scale? So why don't we start with Steve on that one?
Well, I think the big thing is this, while you may be new to the AI factory concept, it's not a new concept. We've built tens of thousands of these clusters to be able to produce AI content, to produce AI results. And so this is not new, it's proven technology.
Kaushik, what are your thoughts?
Yeah, for me, I think the one piece of kind of insight advice, I guess, is that just maniacally focus on prioritization of the projects, and especially when it comes to things that touch end users, whether it's your employees in the organizations or your customers. One thing, don't forget that these are the same people who are using Google. These are the same people who are using ChatGPT at home. And so somewhere that user experience, we take it for granted. And so when you want to build an agentic AI tool, or you want those employees to come in your workforce and start using these AI tools, you have to give the same user experience. And those user experiences essentially 3-dimension, which is the correctness of the data. The second is the speed, right? If Google took 1 minute to deliver the answers, you wouldn't use it as much, right? And the third is the actual UX of how the tool looks like, right? And so these are the same people. So focus on maniacally on end users.
Great points. And Bhavana, what are your thoughts on that one?
So I think Steve and Kaushik covered it very well, right? AI Factory is not just an independent entity. It's a blueprint. It's an industry ready. It's an enterprise grade ready, right? And we are all here to help customers to accelerate their journey, right? And it's all about having a right strategy with the right data, with the right capabilities built, which is all available within the AI Factory. Yeah.
Absolutely. So moving to our next question, the concept of the AI factory we've been discussing brings together compute, networking, storage, AI software, and workflow orchestration all into a unified framework. So how would you guys describe this model in practice, and why is it a game changer for enterprise AI scalability? Kaushik, why don't you start with that one?
Yeah, I think, the reason the AI factory works is it's essentially it industrializes the AI development process, right? And you want, if you are at the helm or one of the key stakeholders of an AI project within your company, what you want is, you want something that is systematic, you want something that is reliable, you want something that is scalable. And the way you do that essentially is that you don't want one-off projects, right? You want to build a platform, where these foster innovation, these factories can bring out ideas together, at scale, and manufacture intelligence. And so the tight integration, right? How all of these kind of manifest, when I talked about the handoff to the relay race, is that it manifests into the tightly integrated, self-service portals, right? And you've got APIs. You've got to think about, how do we experiment, how do we iterate, and how do you ultimately deploy, not bespoke solutions, but AI solutions without reinventing the wheel every single time.
Yeah, great points. Bhavana or Steve, anything to add there?
So for me, right? So it's all. If you ask me today, can anybody work independently? No, right? So always say that team collaboration. Similarly, in AI factory, there are multiple components, right, which comes together and which we have to build together, right? And then with that, we it really matters to have a unified data platform as well, which is available, right? And once you have the unified data platform, having a unified components and the layer bit that is available, right? So essentially it's all combined together, which can be repeated and rinsed, because we are at the era where I cannot build everything from the scratch every time. No, I don't have so much of time, right? So how do I reuse what has been available to me, or how do I reuse what is already built, right? So that's where the AI factory is ready, right? So I want to use that for my multiple use cases and for my multiple address the multiple customer challenges, right? So that's where the AI factory is unique. Yeah.
Well, and to sort of double down on what you're saying, the hardware architecture, the network architecture, it has been optimized over time. We learned what is best. That's why we have rail optimized systems, which means we have one network card to going to each one of the GPUs, things like that. These are lessons we've learned over the last decade. And I think at this point, it really comes down to the software is what defines what you want to produce and what you need to do this. There's certain components that are necessary in that stack, and then there's optional items that are to build whatever your factory produces.
Yeah, great points all around. The next question I have is, can you share any examples of how the AI factory is being leveraged across industries like manufacturing, financial services, or research? And what specific pain points does this architecture help solve? Bhavana, why don't you start with that one?
Sure, Brent. Thank you. Very, very appropriate questions, because all day I keep listening to the use cases from the different customers from the different segments, right? When I think of a different verticals like manufacturing, retail, healthcare, finance, right? So each one comes up with a different requirements altogether, or they have their specific. If I have to prioritize, I have to prioritize some of the requirements as top notch, right? For example, if it's a finance and healthcare, for them, compliance aspects or security, data security aspects are at the highest, right? But when I go to manufacturing and retail, it is more of handling the data, because how my application would handle or manage the aspects which are at the edge, right? Because for manufacturing, they really want to have a computer vision kind of models where it can work on the segments where it is like isolated environment, the edge device where I have a camera fixed, and the visual language models are running around to identify the product design aspects and things like that, right? So to categorize further, right? So from AI factory perspective, I see for the finance, it's like fraud detection, risk mitigation and hyper personalization, especially for the credit card scoring and the loan approvals and things like that, right? And if I go to healthcare, then it's more of genome sequencing analysis, because it takes a lot of GPUs and a lot of precisions required there, and drug discovery use cases, right? Uh, and if I go to manufacturing, it's more of predictive maintenance, anomaly detection, right? So these are kind of the different use cases which comes to my top of my mind when I talk to different customer from the AI for factory perspective.
Absolutely. Steve, any use
Yeah,
cases?
one thing I found is that agencies within the federal government, since I deal a lot with the federal government, a lot of times them and also federal systems integrators, they'll build out what they call a center of excellence. So they use this factory because they're not building just one thing. They have many ideas. And what instead of having shadow IT organizations or having things in the cloud over here and somebody else's hardware, to pull this together into building all the resources so they have all the software, all the hardware, all the resources together, and also keeping control of the intellectual property that comes with that. They're doing this in a center of excellence type of configuration.
It's my favorite, one of my favorite questions. There's just so many amazing use cases every single day that we discover. I think the ones that are closest to my heart, right, are the ones that, essentially are helping, either take humanity forward or like reduce the suffering, right? Or, and so eventually they kind of, a lot of times they are the healthcare use cases, right? The things that are happening in proactive pain management, the things that are happening in cancer research, the things that are happening as a function of different, manifestations of these use cases that are amazing. At the same time, I just saw one where with AI, uh, the proactive management of wildfires and proactive detection of weather disasters, right? These are some of the things that can literally solve so many problems that today we face in the world. So.
Yeah, excellent points and great examples. With that, we're just about out of time. So I want to thank all of you for joining us and for your great insights today, and thank everyone in the audience for joining us as well. If you missed any of the webinar or you want to rewatch anything, the recording will be available just a few minutes after the webinar if you refresh this page. And we'll also send out the link to the webinar on our YouTube channel tomorrow. So thank you again to all of our speakers and to our partners at HPE and NVIDIA for making this great webinar possible. We'll see all of you again next time. Thank you.
Thank you all.
Thank you.